Welcome. This is another video by Tactical Technician from Diagnation. And today's video is going to be, we're going to look at scope signals, in particular valve adjustments. We're going to look right now on the screen. You can see this is a pre-valve adjustment capture cranking. The blue channel is a delta transducer in the intake manifold. The red channel is cylinder 1 ignition trigger. And as you can see, we're frozen on the screen there, and we're going to take a look at what the waveform looks like pre-valve adjustment and post-valve adjustment. We're also going to look at each individual cylinder running, its in-cylinder running compression pre and post-valve adjustment, each cylinder one at a time. So basically you can see the capture here, and I'll kind of zoom in on it. This is a fire cycle, and we're looking at 720 degrees of crank rotation. We're triggered on 1, and we're going to set some rulers up here, and here we go. So this is our ignition 1 trigger. This would be our power stroke for 1, our exhaust stroke for 1, our intake stroke for 1, and our exhaust stroke for 1. Anyway. I don't know if I said it. This is okay. This is our power. I'll do that again. This is our power stroke or a decompression stroke here. This is our exhaust stroke for 1. This is our intake for 1, and this is our compression for 1. So anyway, as we look at the blue, let's take a look at we'll run horizontal cursors down and take a look. This is pre-valve adjustment. Look at the gaps. We're not symmetrical. We got transfer points a little different. This is the triggered cylinder. Anytime you have a vacuum pull next to the triggered cylinder with an even number of cylinders, this would be cylinder one's running mate, which would be 4. So basically, this is the vacuum pull for 4. We go 1, 4, 1, 3, 4, 2, 1, and this would be the vacuum pull for our trigger cylinder. But nonetheless, we can see the little gap here, and this is before valve adjustment, and that's a transfer point. Something happened right here, probably a little early. So when we think about valve adjustment, when valves are too tight, they open early and close later. When they're too loose, they open later and close earlier. So I will take it to the post-valve adjustment capture. I went in there, got the engine cool, pulled the valve cover, got cylinder 1 to top dead center, had the feeler gauges and the proper tools, and I went and proceeded to adjust all the valves. So let's take a look at a post valve adjustment capture, and we'll see the differences and talk about it. Here we go. That was done on right here. We may have different colored channels, but nonetheless, it's still the same signal. I'll make you aware of anything like that. Okay, well, now we're on the same. This is post-valve adjustment, and you can see we're triggered on 1. And take a look at with our horizontal cursors on the transducer. We're pretty equal. See that here, 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 and here. So that's a definite effect of the valve adjustment. That's not always the case. It's all about valve overlap. Valve adjustment is paramount to good valve overlap. There's other things that can affect valve overlap: a warm cam lobe, a tulip valve, a sticking valve. Anything that affects the timing of when the valve comes off its seat will affect these vacuum pulls. But nonetheless, we got a little deal here if you want to split hairs. I'm not going to split hairs on this one. It's a little down, but that's I would consider that negligible. So basically, we've seen a before and after valve adjustment capture. Now I will go to the in-cylinder capture. For each cylinder, I'll do the cylinder 1 pre-valve adjustment running, and then I'll show you the post-valve adjustment. So we'll stay within the same cylinder. I'll write down we'll take measurements of all our angles of when the valves did their things, when they open, when they close, in reference. We'll see the difference of a valve adjustment made on those different angles. So here we'll go to cylinder 1. This is cylinder 1 pre-valve adjustment. Let's take a look at this on the 23rd, and here is cylinder 1. We've got some Okay, this is cylinder one, pre-valve adjustment. So we're gonna take our measurements and we're gonna look at some our four measurement points. I'm gonna talk about these four measurement points. I'm gonna write down that both of these are the important parts of the in-cylinder capture. The first one will be exhaust valve opening. That's about right here. Okay, I will measure that angle, that amount of degrees when the exhaust valve opened. The second one I'm going to call 360 down. You see that little baby dorsal fin there? That's at that moment when it started to go downward from the end of the exhaust plateau. I'm going to measure that in degrees from top dead center. That could be on the downside of top dead center. It could be on the upside of top dead center. Nonetheless, the valve adjustment has a direct effect on that. This right here is the point of deepest vacuum. I'll record that and I'll document that. And this right here, right around when the pressure is starting to ascend, that is the exhaust valve closing. I will document that and I'll write everything down and take a snapshot of everything as part of the video, and you could keep that, and so you have everything documented to the effect of valve adjustment. So this is cylinder one, pre-valve adjustment. Let me get our cursors a little better. What I'm gonna do a vertical zoom, and I'm gonna be uniform throughout all the captures. I'm gonna go 3 times on the vertical zoom with all the captures. And now we're up, and we can see a little more granulated as our angles. So we got good definition. I will take this is the exhaust valve opening. This is the amount of degrees that the before bottom dead center that the exhaust valve opened, and I will measure this and write it down for cylinder one pre-valve adjustment. We're looking at about 27.87 degrees, and I'll write this down, 27.87 degrees. That is before bottom dead center for cylinder one. Our next measurement is going to be what I call 360 down. That's that high point right when the pressure is starting to descend from going up. So right here, the degrees in that, let me kind of get a better measurement. I'm looking about 12.8 degrees. That is after top dead center on the intake stroke. So let me write that down, 360 down. We're talking about 12.8 degrees. Now our point of deepest vacuum, let's see that. Okay, that is, I got 55.74 degrees. 55.74 degrees. And then let's go to the point. This is the tough measurement. We're going to do the intake valve closing. This directly has an effect on our compression tower. So let me kind of key in on this to try to get a good measurement. I'll bring the vertical cursor down. Right when it sort of pops off, it starts to ascend in pressure. That's that piston. The piston is at bottom dead center here, and it starts to move up, but we still have an open valve. The pressure starts to climb when the valve closes, when the piston is moving up on a closed chamber. So I'm going to say about 41.2 degrees intake valve closing. 0.2 degrees intake valve closing. Let me make sure we're still recording. Okay, so you can see that. Now I will go to cylinder one post valve adjustment. Just want to make note, I'm going to try to get this done in one video or two videos. Just bear in mind, if I end it, I'll continue on with the appropriate cylinder. So we're going to look at now cylinder one post valve adjustment, and let's get to that guy. All right, that was done on the 24th, and we'll look at that. Okay, this is cylinder one post valve adjustment. Okay, we got a little different color here, but nonetheless, we'll look at it. All right, let me get here. One thing I will make, I failed to do in the first one. I want to check the compression tower. I will tell you, I did remember that the tower on the pre-valve adjustment was about 80 psi running. Okay, right now we're about 74 and change running. So I just want to document that. I did remember that, but I'll tell you right off the bat, I didn't measure it when I had the cylinder on the capture. But pre-valve adjustment, our tower was 80 psi. Now we're 74 and change. Post-valve adjustment. So let's get in here. Let's kind of get into a fire cycle and start measuring. We want to go here to a tower. We want to go 720 degrees with 4 partitions in between. Let's go to the rulers. 1, 2, 1, 2, 3, 4. Okay. I'm going to stretch it 3 times. Okay. So we can get some granularity in our measurement. Okay. All right. Now we're going to see, right, you can see the definition when that exhaust pocket just starts to change. It pops off its seat. We got good coney, good definition. It not a, which tells us that that valve, there was a change there. That valve popped off its seat, about right there. And the degrees before bottom dead center, I'm going to say about, that's 2418. A little bit, we were 27.8 on the pre-adjustment, 2418 post-adjustment. We're going to go look at our, as I said, the 360 down moment. That is right there. And then I'll get that one. I got to get that one to TDC exactly. And I'm going to see where we are. Wow, we got a change there. That is about I got about 1.5 degrees. We were 12.8 degrees after. So we're 1.5 degrees. 0.5 degrees. That is after top dead center on that. I call that the 360 down moment, that little high spot. And then when it starts to descend, our point of deepest vacuum right here. Let's get this guy a little, we are about 46.8 degrees. We were 55 before, so we look like we have some difference. I will get to the intake valve closing. That is about right. There's our bottom dead center, and here is our, let me get the horizontal cursor to help me out. Okay. Okay. About right there. That's about 3702. So it looks like we have some difference here as far as our pre and post valve adjustment for cylinder 1. I will move over to cylinder 2 pre-valve adjustment and keep going down the line. Let's get to, that was done on the 23rd for cylinder 2 right here, and take a look at what that looks like, and I'll jot the numbers down. Cylinder 2, okay. I'll take a pressure measurement. We're looking at about 81 PSI running. Let's get into a fire cycle. This is a pre-valve adjustment for cylinder 2. And let's get our rulers. 1, 2, 1, 2, 3, 4. And we'll stretch her 3 times so we get more better resolution to analyze our pockets. Okay, so let's get we can see our exhaust valve popping off its seat. Good definition, good, like a shark, like a side of a shark's face popping off its seat. And there's a base to bottom dead center. I've got 28.16 degrees before bottom dead center on cylinder 2, 28.6 degrees before bottom dead center, pre-valve adjustment. Let's go to our 360 down. This is very minutia here. Looks very small. It's almost at bottom dead center exactly. I'm going to call that a half a degree. It's almost at bottom dead center. I'll write it down as 1 degree. So 360 down. I got 1 degree. It's pretty much bottom dead center. So let's bring a point of deepest vacuum on cylinder 2. This is pre-valve adjustment. We're 50, let me read that, 50, okay, 50 point, that's 50.69 degrees, 50.69 degrees, and our intake valve closing on cylinder 2, right here. I'll get my cursor down. Okay. Right when it pops, right when that valve closes, when that piston's coming up, it starts to build pressure. I got 41.3 degrees. Okay, that's intake valve closing. So as we can see, we're our next cylinder to measure is going to be the cylinder 2 post valve adjustment. I'm going to end this video right now, called part 1, and I'll come back with a part 2, which will start with the analyzing cylinder 2 post valve adjustment. Thanks a lot for watching.